A 4-bomb salvo didn't just hit a building, it dismantled a drone war. Ukrainian MiG-29s punched through S-400 and Su-35's coverage. Then programmed Hammers executed 4 different detonation profiles that ripped the heart out of a C-2 hub. In this breakdown, we'll show how each bomb had a job: command room, logistics park, subterranean safe room, and a 3-meter airburst. You'll see how GPS with inertial backup plus laser/IR seekers kept guidance alive through Russian jamming, and how SJU-64 Fuzes sequenced the final blows. Before we move on, please take a moment to subscribe to the channel and like the video. If S-400 see everything, how did 2 fast movers reach the release window without dying on radar? They started where big radars hate to look, down in the ground clutter. The MiG-29s rode under 100 meters above ground level, throttles trimmed to keep exhaust cooler and reduce the plume that infrared sensors love. The route wasn't a straight line. It bent with the folds of the terrain, using ridge lines to block line of sight and to force search beams to graze instead of stare. Bars R sweeps on Su-35s ran in predictable patterns. The crews planned time on target to cross when those scans pivoted away. Overhead, an A-50 could stitch the picture together, so the jets treated every second above the horizon line like borrowed time. The trap was layered and patient. S-400 long-range search kept the big circle alive, pushing tracks to intercept controllers. Su-35s and Su-30 flows along cap orbits with vectors ready to tighten. Near the target, short-range Thor batteries waited to catch anything that slipped through, backed by Pantsir search modes hunting for low flyers. The MiGs entered that web, knowing a pop-up meant they were going to be seen, just not for long enough. Ukraine's playbook leaned on discipline. Altitude stayed low, not roughly low, but a hard cap below treetop masts. Power changes came smooth to avoid heat spikes. Defensive programs weren't improvised. Chaff and flare ladders were pre-briefed by distance and threat sector, keyed to the moment a radar warning tone would flip pitch or a missile warning would pulse. Comms stayed terse. The goal wasn't stealth in the Hollywood sense. It was to look like noise until the last possible second. They brought an EW shield. A TB2-style decoy moved on a flanking axis, broadcasting and probing to tug attention and cue emitters. At the same time, Ukrainian ground electronic warfare flooded known Russian listening posts with energy, cluttering bearings, and degrading clean tracks. That wall of interference didn't erase the jets, but it forced the defenders to separate wheat from chaff while the clock ran. Here's the radar math in plain terms. At very low altitude, the radar beam has to scrape along the surface. Returns bounce off dirt, trees, buildings, everything. A small target at a shallow grazing angle blends into that mess. It doesn't make the aircraft invisible. It buys seconds, not minutes. Seconds to cross a valley, knife behind a knoll, or slip past a sweep as it rolls through azimuth. Russian counter-EW didn't sit idle. Systems like Krasuka and Shapovnik Aero worked to jam, listen, and sort emitters. Pantsir S-1 rotated search modes, dragging its own radar net for low targets that might dash in. The answer to that was tempo. The MiGs avoided steady profiles. They held low, then snapped into short, high-speed pop-ups that were too brief for long dwell, or for engagement chains to complete cleanly. The climb to release was the hard trade. AASM Hammers need altitude to glide. Too low, and they fall short. Too high, and the jets sit inside no escape zones for long-range missiles. The crews chose a near-suicidal middle, an aggressive pull to touch the edge of the engagement envelope, pitch stable just long enough to feed coordinates and settle the solution, then a break back into the weeds. That window was timed against Bars R sweep gaps and masked by the decoy's emissions spike. So how did they penetrate S-400? They didn't duel it. They bent time and geometry, spoofed sensors with noise and decoys, and used a short, violent climb to kiss the ceiling, fire, and vanish into clutter before the net could tighten. Those seconds bought the salvo its path. Now the burden shifted to the weapons, which had to steer, filter, and hit through heavy jamming, while the sky behind them filled with search beams and contrails. One target, 4 different explosions. Why program 4 bombs to think differently? Because the job wasn't blowing a hole in concrete. It was shutting down a brain that controlled drones, radars, and relay links. The Hammer family in the 340-kilogram class brings modular guidance and a programmable SJU-64 smart fuse that decides when and how to detonate. Crews set timing, height, and penetration logic before takeoff, tying each warhead to a specific piece of the network. Each bomb carries the same body and glide kit, but the brain and fuse profile shape what happens at impact, above it or deep inside it. Russian electronic warfare pushes back at every step. GPS bands get flooded. Terminal seekers see false returns. Hardened rooms host servers behind blast doors, while decoys and vehicle parks pull aim points away from the command knot. The Hammer counters with a layered guidance stack. GPS runs primary for accuracy. If RF interference chews the signal, inertial sensors keep the path credible without broadcasting. In the last seconds, the kit can hand off to a terminal option, laser or IR, to sharpen the aim on a hot roofline, a lit doorway, or a designated spot the pilot marked during the climb. Mid-course filtering trims noisy inputs, rejecting jumps that don't match the flight model, so the weapon stays on a believable vector, even while the spectrum churns. Hammer 1 went for the command room. Its job was to kill the C2 node, not merely scar the roof. It wrote GPS/INS to the footprint, while RF filtering kept the course stable under jamming. Near the aim point, the terminal seeker refined the track, locking onto a consistent feature and scrubbing the last meters of error. The SJU-64 was set to detonate inside the volume, not at the wall. That delayed logic let the case punch through, then blow in the space where consoles, racks, and fiber converge. One detonation like that prized the spine out of coordination. Hammer 2 hit logistics on the surface. Vehicle parks are soft but spread out, with generators, antenna masts, cable spools, and fuel. This one didn't dig. It burst just above the ground to throw a sheet of fragments sideways. The airburst height was tuned by the fuse to drive metal across open bays and over parked gear, shredding cables, and ripping vents on shelters. Antennas don't survive that. Neither do exposed power units feeding the uplinks. The goal was to cut the legs, so the brain that survived couldn't talk or move. Hammer 3 targeted the subterranean safe room. Most command posts hide a reinforced box below grade, tied to hardened trunk lines. The SJU-64 ran a delayed mode long enough to penetrate, then detonate internally. That collapse breaks beams, jars, servers off mounts, and, more importantly, severs fiber trunks that route data to the wider network. Even if radios remain, the backbone goes dark when those cables shear under debris. Hammer 4 finished the space between. Its fuse set a 3-meter airburst to push fragments through doorways, corridors, and open work areas where staff shelter when the first hits land. That height builds a dense fragment field at human level. You don't need a direct strike to make a node unusable if every corridor becomes a channel of shrapnel and every exposed position turns lethal. Why 4 bombs with 4 mines? Redundancy under EW pressure is survival. Different fuse behaviors and seekers force the defender to counter multiple problems at once. You can jam GPS, but inertial carries. You can harden a room, but a delayed blast cancels the sanctuary. You can scatter gear, but a tuned airburst wipes the grid. The result is a high chance that at least one bomb crushes the core, while the others strip the support that keeps it breathing. With the Nexus blind and burning, the pilots still faced the exit through missiles and hungry fighters. Mission success hinged less on the jets and more on weapon logic. 4 tailored detonation profiles dismantled a command network by design, not accident. Programming set the timing, height, and penetration. Then guidance stacked GPS, inertial, and infrared to ride through interference and finish the job. The next fight is software versus sensors. The side that programs faster wins longer. That race already shapes tomorrow's airspace.